In this lesson, we will be discussing Introduction to Uncertainty. So what is uncertainty? So in many sciences, and physics in particular, it is very important to be able to make the most accurate measurements possible. The problem, though, is that there isn't a method for making perfect measurements, no matter what instrument you use. This is where the concept of uncertainty comes into effect. Uncertainty keeps track of how accurate a measurement is and depends upon the measuring tool you're using. So let's look at an example. In the picture below, a card is being measured by a ruler. From the measurements, we can see that the card is 49 millimeters or 4.9 centimeters wide. However, what if the card is actually slightly smaller or larger in width than 4.9 centimeters? Our measuring device, the ruler in this case, can only measure down to the millimeter scale. Therefore, to account for this, we say that the uncertainty in the measuring device is half the smallest unit of measurement possible. So what would the uncertainty in this example be? Take a minute and stop the video at this point and well, since the uncertainty is half the smallest unit of measure, and our smallest unit of measure is 1 millimeter, then the uncertainty would be 0.5 millimeters or 0.05 centimeters. So now that we have found the uncertainty in the measurement, we need to be able to let others know what that uncertainty is. Remember that in physics, we must always carefully document our work so that we can review and possibly learn from it. When we do so, what we are writing down is what is known as the estimated uncertainty. We would write the estimated uncertainty for our example as follows. We would either say it's 49 plus or minus 0.5 millimeters or 4.9 plus or minus 0.05 centimeters. Here we use the plus or minus symbol to indicate that the actual width of the card could be somewhere between 48.5 millimeters and 49.5 millimeters, or 4.85 centimeters and 4.95 centimeters. So oftentimes it may be useful to write down how accurate your measurements are using percents. When we do this, we are writing down what is called the percent uncertainty. The formula for writing down the percent uncertainty is very simple. It is approximately, and note that when I say approximately, equal to the ratio of the uncertainty to the measured value multiplied by 100. And here's a formula for it. So for our example problem, our uncertainty was 0.5 millimeter or 0.05 centimeters, and the measured value was 49 millimeters or 4.9 centimeters. Therefore, if we plug these values into our formula, we can calculate the percent uncertainty. Doing so, we get the following. See that the percent uncertainty is approximately equal to 0.5 divided by 49 times 100, which tells us that our percent uncertainty was approximately 1% in this case. With this, I hope you have a better understanding of uncertainty, estimated uncertainty, and percent uncertainty.